So here's my parabola. Let's see the y value of the vertex when the parabola opens up. Well, the y value is going to be our, that's right, minimum value. Number 4, hk, where y equals a times the quantity x minus h squared plus k. What's the hk? The vertex. Let's see, what do they got up here? Vertex of the parabola. Number 7, the y value of the vertex when the parabola opens up. Well, let's make one opening up. Oh, sorry, opens down. I made a mistake. Oh my goodness. That's okay. There it is, opening down. My issue? I don't have any issues. Well, I wouldn't say I don't have any issues. That's the wrong thing to say. Okay, so the y value of this one is going to be, that's right, kids, the maximum value. And number 8, where I just have y equals a times the quantity of x minus h squared plus k. All together, kids. Vertex form. Very good. Very good. And a shift, I say shift, of the graph horizontally or vertically. Bless you, myself. Translation. Okay, did we get them all? Huh? Did we get them all? Does that make you dizzy? Yep, got them all. Okay, kids. As Bob Seger would say, turn the page. All right, some more notes that you can use on the quiz. Let's see, standard form of the quadratic we just went over. Y equals ax squared plus bx plus c, where a cannot equal 0. What if a did equal 0? Then it would be a linear equation. Very good. Okay, this whole thing about a is greater than 0, the parabola opens upward, and if a is less than 0, parabola. We know what the translations are, right? If a is negative, what happens to my parabola? Flips or opens downward? If a is between 0 and 1, what does that mean? A between 0 and 1. That's right, kids. It's a fraction between 0 and 1. What happens to my parabola? Oh, you guys are on top of things today. It's wider. And what happens if a is greater than 1? Very good, narrower. All right, what else we got here? Oh, the vertex. The vertex from the standard form, well, the x-coordinate of the vertex is negative b over 2a. How do I get the y-coordinate of the vertex? That's right, kids. Plug x back into the equation. Okay, what else are you going to need to know? Oh, when we were doing our parabolas manually, days and days we spent on the bookwork and notes and stuff. I was kind of hoping, I even hinted it a couple times, that the C in standard form, that's our y-intercept. Okay? The y-intercept is 0, c. That's where it crosses our y-axis. Okay, anything else we should know? Did we get everything? Is that it for standard form? Did I miss anything? Huh, kids? I think I got everything. Okay, let's do the examples. Number 1, which function is written in standard form? First one or second one? Very good, kids. It's the second one. Number 2, which is the x-coordinate of -5? Which has an x-coordinate of -5? First one. Wow, that's stupendous. Which quadratic has a y-intercept of 2? No. Wrong. Second one. Oh, wait, I'm not supposed to say that. Good try, Patrick. Okay, number 4. Which parabola opens downward? First or second? That's right, the first. It has a -a. Okay, future presidents and senators. Yes, it is. That's why I'm getting in the spirit. Okay, let's take a look at vertex form. Vertex form is the f of x or y equals a times quantity x minus a squared plus k. And again, a cannot equal 0, otherwise we would have a linear equation. Okay, the same thing holds true for a. Let's rewrite everything. If a is negative, our parabola flips or opens downward. Oh, class is over. If a is between 0 and 1, or a fraction between 0 and 1, what happens? Wonderful. And if a is greater than 1, narrower. It isn't math. We get to make things up in math. Okay, what else? Oh, the vertex. Okay, actually, this is the easiest form, right? Because we can pick the vertex out immediately. Is that it? Anything else? Oh, I just thought of something. Which way does it shift? My H. Shift. Left or right? And what does my K do? Shift. Up or down? Anything else? Anything about vertex form? Anything? All right, let's do number 5 examples. Which function is written in vertex form? First one, wonderful. Number 6, which quadratic has a vertex of -2, 4? -2, 4. Beautiful. It's opposite the sign inside the parentheses. Number 7, which parabola opens upward? My A is positive. Now, on the last quiz that we had some problems where you had this standard form of a quadratic equation, or I think we had a graph or something, and you had to put it in vertex form. You're going to have to be doing this quite a bit for this unit, where we're going to go from vertex form to standard form, not so much, more standard form to vertex form to general circle form, and so on, perfect trinomial square form, and so on and so forth. And so you might as well get used to it. And on the last quiz, we didn't do so well on that. Now, what form are we in this problem, number 8? Number 8, what form are we in? That's right, standard form. Okay, we're in standard form, and we want to go to vertex form. Okay, and we're going to do that. How? Well, let's look at our charts here. All right, see you later. Class is over. All right, so let's see. We need our A, B, and C, right? So what's our A? What's our B? And what's our C? Okay, what's our vertex? Or the x-coordinate of the vertex. Stop throwing things in my ceiling. You nut. How do I get the x-coordinate of the vertex? That's right, negative b over 2a. So negative 6 over 2 times 1 equals positive 6 over 2, which equals, that's right, kids, 3. How do I get the y value? Very good. Plug it back into the equation. So I have y equals 3 squared minus 6 times 3 plus 12. 3 squared is 9. 18 plus 12. Let's see, 9 plus 12 is 21 minus 18 is 3. 3. Okay. What's my H? H. It's 3. What's my K? So I have y equals a times x minus h squared plus k. So my a is 1. X minus, what's my h? Squared plus k, which is, there's my answer. These things are going to be a lot of work, okay? Completing the square when we're changing formulas is going to be a lot of work, especially going from standard form to general circle form. No way around it. Any questions on this? You guys have all the notes because you're going to be able to use this on the quiz. Take a picture of that pencil in the ceiling so I can email it home to your parents. That's the problem. Sure. Okay, now, you guys have always asked, well, what are we going to use this stuff for? What, what do I learn? Why do I have to learn this? What's it for? Okay, all the stuff that we've been learning is your base knowledge of application problems, right? Because in real life, your boss doesn't come up to you and say, hey, what's the Y value of flipping burgers? Okay, they don't ask that. In a minute. They ask, well, how high can you flip that burger? Right? So, all this stuff that you've been learning, we're going to be applying it to real life problems. Let's do some real life problems. Are you ready, kids? Are you ready? Are you ready, kids? Aye, Captain. Hey, an object's height launched on Earth can be modeled by the function h equals negative 16t squared plus v naught t, I like to say v sub 0 t, plus h naught or h of 0 or h 0. Okay, let's define these. It depends on what teacher you had and how old they are. Older teachers will say h of 0. 110. Older teachers will say like h of 0. Newer teachers or younger teachers will call it h naught. All right, so let's define some of these. What do you think h is? The first h. Anyone? Anyone? Bueller? 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 What do you think the first h means? Height. Who said that? Very good. Very good. That's going to represent the height. If h represents height, what do you think the t represents? Time. Well, there you go, kids. Okay. V sub 0 or V naught or V0. What do you think, kids? Good educated guess, but no. I mean, great try. Try again. You get an award for trying. Everybody gets an award. Initial velocity. Did you? Wonderful. Do we have any physics people in here?
What?
Physics people? You may know these computations by heart. What h of 0 do you think? Initial height. Wow. That being different from this h, which is the overall height, correct?
Yep.
Okay. If you're in a science nut or in physics, you know what the negative 16 coefficient represents, right?
Yeah.
What is it? It's actually negative 16 feet per second. Does that help? Any guesses? Huh? Negative sign feet per second means something's going down. Anybody? 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 It's gravity, right? That's the speed of gravity or velocity of gravity. Okay, since we're the only country in the world that uses the standard system, everybody else uses metric, right? Everybody else is going to say meters per second. No, it's not. Nope. 9.8. Who said that? That is fantastic. 16 feet is converted to 9.8. Okay. Yes, it is. All right. So be careful when you're doing these application problems because you don't know if you're going to be multiplying by 16 or 9.8. All right. Are you ready, kids? All right, let's do an example problem. You ready? You ready? You ready? A rocket is launched directly upward at 45 feet per second. What do you think that is? We'll keep going on. Okay, a rocket is launched directly at 45 feet per second from a platform 70 feet high. Any ideas? Initial height. So it's going to be our h of 0. Is given by the equation s of t equals negative 16t squared plus 45t plus 70. Now, think about this again. 45 feet per second. Think of your car. What's the labels in your car? Speed. Miles per hour. So what do you think this 45 feet per second is? Velocity or height? Velocity, right? This is our initial velocity. It's our v sub 0. So the initial velocity of the object when it is initially launched, 45 feet per second. Are you with me? I'm still not sure what is this S of T business. Should be H of T. I don't know. What will be the object's maximum height? So let's think about this for a sec. Let's draw us a little picture. All right, so we're starting at an initial height of 70 feet, right? And this rocket blast off. It's going to go and then reach a certain height, then it's going to drop back down to the ground, right? So that's the graph of our little rocket man. Okay, so here's my x-axis. Here's my y-axis. All right, we already said that the y-axis is our height of 70 feet, right? So when we're looking for the maximum height here, we're looking for this point there, right? What describing this point, what are we looking at here? It's a parabola. It's part of a parabola, right? It's the maximum value, right? So it's the maximum value. Guys, knock it off. Come on. It's going to be the maximum height or our y value of the vertex. Okay, and actually, since our y-axis is the height, we're going to change this to h. Okay. Now, if our y-axis is the h, that's our maximum height. What do you think our x-axis is going to be? Well, the ground, and you're right. It's. By the way, the rocket has to stop at the ground, otherwise it what? Goes straight to hell. So it's got to stop at the ground. But what are we looking for here? What are we looking for in the formula? What's the variable? Fine, you can tell me. What's that variable? Time. T. Yeah. That's time. Okay, our x-axis is time. Okay, so we're looking for this question C, how many seconds have elapsed when this height will be reached? So we're looking for the x or t value of the vertex, right? All right, ready, kids? Are you ready, kids? All right, so here's our t time. Here's our h height. We can actually, now remember, this is our independent variable. They're asking us to choose 1, 2, and 3 for the time. That's our x value, right? We're going to plug these into our calculator and get what the y value or the h value is. Are you with me, kids? I'm going to use my calculator. So I have -16, and my t is 1. I'm going to have 1 squared plus 45 times 1 plus 70. And I get 99 feet. Correctamundo? Yes. Yes. All right. So we got to do that for 2 seconds and for 3 seconds. Well, let's go ahead and do it. Let's see, my calculator, I can copy and paste. And then just substitute in 2. But you guys, I think, have to retype everything. So I'm at 96 feet, and then at 3 seconds, I'm at 61 feet. So what's happening here? Yeah, it's going, we got it on the downswing here, the down low. Questions? Okay. So they want us to find the rate of change, or the rate of change from height to 1 to 3 seconds. Anybody remember what the rate of change is in mathematics? Does anybody remember what rate of change is? Yes, you did. Yes, you did. It's the slope. Okay. Yep, rate of change is slope. So we're going to, you remember the formula for slope? y2 minus y1 over x2 minus x1. In mathematics, we don't use y2 minus y1 over x2 minus x1. We use the change of y over the change of x. And that little triangle symbol is called the delta. So I have delta y over delta x. In our case, we're actually doing delta h over delta t. Okay. Now, our delta h is my y values, right? 61 minus 99 over 3 minus 2. Negative 38 divided by 2. Negative 19, negative 19 feet per second. Now, can I have a speed or velocity of a negative number? I can't. Okay. The reason why it's a negative is because it's on that down curve, but it's speed a positive. It's like distance. Okay, it's got to be a positive. So in actuality, that's positive 19 feet. Now, if you leave it at negative 19 feet, I'm not going to take off. No big. Are you ready, kids? Aye, aye, Captain. All right, so you guys do number 2. So this is my height, and this is my time. Okay, where am I starting at? 120. By the way, what would that be in our equation? H of 0, right? Okay. The initial height. So I'm going to be dropping this thing, and it wants to know how long it must fall till it hits the ground. Okay, there it hits the ground. So I'm looking for this distance here, right? What? Here, fill it out. Okay. Let's see. What's our initial velocity right at 120 feet? How fast is this thing going at 120 feet? 0. So that's our initial velocity. Do we have everything we need to build an equation? Okay, so we have the h of t equals negative 16t squared plus our initial velocity, 0 times t, plus our initial height is 120. Okay, so we get negative 16t squared plus 120 I can't give this. Now, we could do this one of two ways. We could do it manually, or we could use our calculators. Which way do you want to do it? Oh, man, I thought you were going to say that. So I'm going to do it in the calculator. All right, what are we looking for here? Yeah, but what is the answer? And what am I pointing at? Yeah, I'm looking for this space here, but I'm looking for that point. What is that point? The x-intercept, right? It's hitting the x-intercept. Okay, so what I need to do on my calculator is find the x-intercept. So, remember we did this last week? Our y equals let's see, we've got negative 16. We have to use x because we don't have a t. Squared plus 0, x plus 120. Graph it. And we're just looking for that intercept point, correct? So what I'm going to do is go to our second trace. I need 0 for x-intercept. Hit enter. My cursor here is way off base. Oh, there it is. Okay, my cursor left to the point, hit enter. Right to the point, hit enter. Then hit enter again. And what distance is that? How much time went by? That's right, 2.73 seconds. Let me show you something on the calculator. Okay. Now, when we put this in the calculator, this is where you guys are going to have to kind of finesse and find things on your calculators. Okay? Now, what I'm going to do is, I know, listen, this is important because you're going to need to know how to do this for tests and quizzes. I know that x-intercept is between 2 and 3. So I'm going to go to my window, and my x minimum, well, I don't need it a negative 10. I need a 0 there. I'll maybe negative 1. And I know I only need to go up to 3, so maybe I'll put 4 there. Okay. My y min, I know I'm starting at the ground, so again, that's 0. And I don't know what the max is. I'm just going to leave it at 10, and then I'm going to graph this. And I still can't really see my parabola. I know that my y-intercept is what? 120. It's my c. So I'm going to go back to my window. And my y max, I'm going to put at 120. That way I should get my whole parabola in there. Isn't that cool? Now it's a lot easier for me to get that. I'm going to put my y min at negative 1. Now it's a lot easier to get that point. Okay. Do our second trace, our 0. I'm to the left of that intercept. So hit enter. And now I'm going to be to the right of that intercept. Hit enter, enter again. And I get my 2.73. Now, I told you we were going to rely heavily on these calculators. We're going to do enough problems where you'll be able to do this on a calculator like that, if you pay attention.